Hi students, this is Data Arbology Physics faculty. Here I would like to give a lecture on optical fiber. In this video I explain about the propagation of light in a gradient index optical fiber, simply called as GRIN fiber. We know in case of gradient index optical fiber, the refractive index profile is the parabolic refractive index profile is appears like this. This is a refractive index profile. This is the cladding and this is the core. So for this core, at the center the refractive index value is maximum, and when we are moving towards the cladding region, the refractive index values gradually decreases. When the light is launching into gradient index optical fiber, which is travels in a helical manner, and such a type of rays are called skew rays, and here the ray does not crosses the optic axis for each total internal reflection phenomena. Now how it is possible in gradient index fiber, this is I will try to explain it here. So this is the gradient index optical fiber. So in the core you have different layers are having different refractive indices values. That refractive indices values are like N1, that is the inner core refractive index value is greater than Na, greater than Nb, greater than Nc, greater than N2 is the refractive index of the cladding, right? I will make it zoom, right? Now, according to Snell's law, when a ray travels from rarer media to denser media, it bends towards the normal, and when a ray travels from denser media to rarer media, it bends away from the normal. We know that. Now here we are launching the light. The light here which is travel from air to glass. It means you are traveling from rarer media to denser media. It bends towards the normal. Now it is inside it. Now this ray is traveling from the refractive index N1 to refractive index Na, but N1 greater than Na. So here the ray travel from denser media to rarer media, so it bends away from the normal. Later it is traveling from Na to Nb. It means it is traveling from denser media to rarer media, so it bends away from the normal. Then it is from Nb to Nc, so here also it bends away from the normal. Finally it is incident on the cladding, the interface of the core and cladding, and here the incident angle is more than critical angle. The ray is reflected in the same media. Now the process is reversed. Now the ray travel from Nc to Nb. It means you are traveling from rarer media to denser media, so it bends towards the normal. Later it's traveled from Nb to Na. It means we are traveling from rarer media to denser media, it bends towards the normal. And then it is traveling from Na to N1. We are traveling from rarer media to denser media, it bends. So in this way, here the rays travels in the path of helical manner. So in each total internal reflection phenomena, it does not crosses the axis. Such a type of rays are called skew rays. So in optical gradient index optical fiber, the ray which is launching into the fiber is travel in an helical manner. It means in the form of spring. The signal which is travel from one end to other end. Whenever the signal travel in the form of helical manner, the distortion and dispersion losses are becomes very small. So with compared to the step in the single mode optical fiber, here the dispersion and the distortion losses are very less. This is the advantage with the gradient index optical fiber. So when we are observing, this is a simple diagram. The first one is step index optical fiber. In case of step index optical fiber, throughout the core the refractive index value remains same, and cladding having its refractive index. These are represents the number of modes propagating through the optical fiber. So this is a given signal and this is obtained signal. So here the dispersion losses or the communication losses are more. And the next one is gradient index optical fiber. In case of gradient index optical fiber, this is a parabolic profile of refractive index, right? And this is a given signal. Here the rays are travel in an helical manner. It is travel in an helical manner. So this is the outside signal. In case of single mode optical fiber, here only one mode is propagated from one end to other end, so its dispersion losses are very less. This is indicated in this diagram.